This video is over Lesson 79, Transforming Formulas, and it is for my pre-algebra classes. So, ladies and gentlemen, in this lesson, we're going to be taking several different formulas. You can see a few of them there on the screen already. And we're going to be solving them for different things. So if we take a look at our first example here, the distance formula, this is a formula that you may have seen in science a few times. It gets used a lot there. D equals RT. So D here stands for distance. R stands for rate or rate of change. In that case, if you're looking at how your distance is changing, T, by the way, is time. So if you're looking at how your distance is changing over time, well, that's your speed. So actually, R is your rate of change or your speed. And so the way this is set up right now is it's set up basically to calculate distance. So it's basically implied here that you're going to go out, you're going to find your speed, you're going to find your time that you're traveling, you'll multiply the two of those together and you'll calculate your distance. So in science class, if you knew a bunch of speeds and you knew a bunch of times, you could use this formula to quickly multiply them together and find the distances traveled. However, what happens if you know the distances and you know the time, but we want to find the rate of change or we want to find the speed? Well, I mean, you could plug in your number here, you could plug in your number there, and then use your algebra skills to solve for R. But we don't want to keep doing that over and over and over again in science, especially we often have several different pairs of data that we want to plug in. So solving each and every single equation is just going to be time consuming. And so that's where today's skill comes in. I want to take this and I want to solve for R. I want to solve for R. Another way that we can say this is we want to isolate R, meaning that we want it to say R equals. We want R to be the only thing on its side of the equation. So with that being said, let's go ahead and do this. So D equals RT. Remember, to solve equations, we use SADMEP. So we're going to undo things in reverse order of operations. So, well, there's really only one thing to reverse. So if I want R by itself, that means I've got to get rid of T. So R and T are connected by multiplication. So what will cancel that out? Division. We always divide both sides by the same thing. And since over here what I'm multiplying by is T, then when I divide on both sides needs to be T as well. And so this T will cancel that T, and that will leave R all by itself. Now on the other side, I don't know what D is, I don't know what T is, and so therefore I can't reduce those, I can't simplify them. So that really is just going to be D over T, and of course fractions mean division. So flip this around just so it looks the way we usually like to see it when it's solved for R. R equals D over T. So if you're sitting in science class and you have this formula and you need to find a bunch of speeds, well, quick little algebra, and we see that all we got to do is take our distance divided by the time. And so that would be our new formula. Over here, let's take a look at a perimeter of a triangle. So perimeter of a triangle, P equals A plus B plus C. That works for all triangles, just means add up the three sides. So let's say that we want to solve specifically for side C. So P equals A plus B plus C. So consider, what do we need to get rid of to get C by itself? Well, I need to get rid of the A and I need to get rid of the B. How are they connected to C? Well, they're both being added with C. So then think about your SADMEP. We're going to go ahead and get rid of this by subtracting. So this is a positive A, so I will subtract A on both sides. Over here, P and A are not like terms, which means that they will not combine. This will just be P minus A. And then over here, the A and the A will cancel. because a minus a will be 0, and that will just go away. So then we're going to be left with b plus c. Well, I want to get c by itself, so now I've got to subtract b on both sides. Now once again, p, a, b, none of these are like terms. None of them have the same variables, the same letters. So that means none of them can combine. So this will just be p minus a minus b. And on the other side, the b's will cancel, leaving me with c. Now I'm just going to take one more step here just to flip this around. C equals p minus a minus b. And that shouldn't be a great surprise. Take the perimeter, subtract the other two sides, you get the third side. Temperature, this one's going to be a little more challenging. So for temperature, we've got our formula here for how to calculate Fahrenheit when you know Celsius. But the trouble is, what about when I know Fahrenheit, but I need to know Celsius? So we're going to solve this for Celsius so that way we can calculate Celsius. So F equals 9/5 C. And I'll make a little note here about this 9/5. When we're dealing with equations, we really don't like mixed numbers in the middle of them. So 9/5 is better than 1 4/5. We don't do 1 4/5 in an equation. All right, finish it off, plus 32. Now, it's going to be SADMAP, remember, that we use to simplify this. So the 9/5 is connected by multiplication. The 32 is connected by addition. So therefore, SADMAP, well, the addition is going to get canceled first. So I'm going to subtract 32. Over here, F and 32 are not like terms. One of them is a variable, the other is a constant. On the other side, my 32s will cancel, and that'll leave me just with 9/5 C. Now the 9/5 is connected by multiplication, so normally we would divide both sides by this number. However, remember, we don't divide by fractions. Instead, we multiply by their reciprocals. So I've got to do that to both sides, though. So on this side, I'm going to multiply by the reciprocal, 5/9. And if you write it like this, that is wrong. Because we need to multiply 5/9 times the entire side. The way we have this written right now, we would only be multiplying 9/5 and F. So in order to make sure it's the whole side, I need to use parentheses to group that side as one thing. So I've got to pay attention to that in multiplication. On the other side, I got my 9/5 C times that 5/9. So we multiply both sides by 5/9. Now to finish it off. So 9/5 and 5/9 will cancel each other out. That leaves us with just C. Over here, I can distribute my 5/9 in to the quantity there inside the parentheses. But here's the thing. Will 9ths and 32 simplify? Or in other words, does 9 go into 32 nicely? Well, it doesn't. So this is one time where we might actually, for the sake of the formula, keeping it simple, we might just want to leave the parentheses in. So that way we'll take our number of Fahrenheit degrees, subtract 32, then we'll deal with the fraction. So flip it over. C equals 5/9 times the quantity, F minus 32. So if you know the Fahrenheit, take your temperature in Fahrenheit, subtract 32, take that result, multiply by 5/9, and you've got Celsius. Moving on to perimeter of a rectangle. So let's say right now this is set up so that way if you know the length and you know the width, you can quickly calculate the perimeter. But let's say I know the perimeter and I know the width, so I want to calculate what's the length. So copy the equation down. And now we need to solve for L. So 2W here is being added with 2L. So we're going to treat 2W as one term that's being added. and then the 2 is being multiplied with L. So we've got 2W that we're adding, we got 2 that we're multiplying by, so SADMAP tells us to subtract and add first. So I'm going to subtract 2W from both sides. Once again, P and then 2W are not like terms. This has the variable P, this has the variable W, they are not the same. So this is just going to be P minus 2W. It's not going to simplify. If they're not like terms, they're not going to simplify. They'll just be whatever it says. So that is for addition and subtraction, though. Multiplication, division is a different story. So over here, so the 2W's are gone. So we're left with 2L. Now, I need to get rid of this times 2. So to get rid of my times 2, I'm going to divide both sides. And this is part of the reason why I've tried to make such a big deal about drawing your lines in and going under the whole side, is because if you do not go under the whole side, you could very, very realistically end up getting this wrong. So divide both sides by 2. So over here, the 2 and the 2 will cancel. That'll leave me with just L. On the other side, you might be tempted to cancel your 2 with your 2. If you do that, you're wrong. And I'm going to go to my dry erase board to kind of help explain why. So let's say I had 2 times 3x minus 5. By now we should be familiar enough with the distributive property that we understand that this is going to distribute over the subtraction. And so what I'm going to end up with is 6x minus 10. So here's the thing. If I have 6x minus 10 and I divide that by 2, so we got this because we multiplied by 2. So if I divide this by 2, it should go back to this. Well, if you try canceling just these, so that'd be a 3, that'd be 1, you get 3x minus 10. Well, that obviously can't be right. So if I had my 6x minus 10 over 2, and I try reducing these, then I get 6x minus 5. Well, once again, that can't be right either. So ladies and gentlemen, here's what I've been trying to build up for you for a while now, is that just as things will distribute in multiplication, they also distribute in division. So dividing this by 2 will actually distribute dividing that 2 with both of the terms in the numerator. So then this will become 6x divided by 2, which is 3x, and 10 divided by 2, which is 5. So the point there that I'm ultimately trying to make is that when I have something like P minus 2W over 2, the only way I could reduce this 2 and that 2 is if this has something as well that could be divided by 2. Now, since there's nothing here with the P that can be reduced by 2, then I can't reduce it at all. Okay. Alternatively, if instead we had something like a 4P, if that was our equation or our expression, then in this case the 2 would distribute and I'd get 2P minus W. But that's not what we have, and so therefore that's not what we can do here. So if you run into this situation where these can simplify, but this can't simplify with it, then you can't simplify it at all. So it's all or nothing. Either all the terms can reduce or none of them do. So this will just be P minus 2W over 2. And if I flip it around real quick, L equals the perimeter minus 2 times the width, and then divide that by 2. And I'll circle both these answers here real quick. All right, and here we are. Next up, we're looking at circumference. So usually we know the diameter or the radius, and so we use one of these two formulas then to solve for our circumference. But what if it was the other way around? What if we knew the circumference, but we wanted to then figure out what is the diameter or the radius? Well, in that case, we need to solve. So c equals pi d. So in this case, it's pi that's being multiplied with d. So to cancel that out, I will divide both sides by pi. And so pi and pi will cancel. That leaves me with d. And then over here, this is a variable, that's a constant. They are not going to be able to reduce it all. So c over pi. One last step, flip it around. D equals pi over, or c over pi. Goodness, tripping over that one. D equals c over pi. And that's it. And over here, obviously, then we're going to solve for r. So c equals 2 pi r. Now this time I have two things that we're multiplying with r. For the sake of speed and ease, we can actually divide both sides by both of these things. If I divide both sides by 2 pi, then the 2 can cancel with the 2, and the pi can cancel with the pi, which will leave me with just r. And then just like on this one here, there's nothing here that we know that can simplify, so this will be c over 2 pi. So the radius equals the circumference divided by 2 pi. And that, ladies and gentlemen, is the end of our lesson.